Hi guys, here we are for yet another part of our Formatables Refactor. So we've done the release for Sprint 28 and we're now Sprint 29, and as I explained release notes, we are now down to the helper types. So what we've done since we finished the release in the sprint and all that stuff, all the paperwork effectively, we had a quick look and we figured out how to attack the helpers. And what we're going to do, what we've already started, is we just copied across a couple of types, not many, the C++ helper descriptor and helper properties. And as it turns out, the C# ones are fairly similar, so we're hoping that we can get away with similar types for this. We slotted into the element itself as helper properties, just a little list there. We've generated this already, so if I jump over to my compilation, you can see it's all generated. We build the latest code generator and we'll just generate everything. So that shouldn't really do very much. So these types are there, they're slotted in. So what we're going to do for this video is see if we can get rid of as many types as possible related to the helpers. The first task is going to be to make the helper expander work in terms of those types defined in the logical model. That already gives us a bang for the buck, because once we've got that, we can get rid of element properties. And once we get rid of element properties, our formattable roughly becomes the same as a logical physical region. So at that point in time, I'm hoping we can unwind all of the formattable model stuff. I mean, we can't actually get rid of these transforms here, but we can get rid of a lot of types in this model. I think we will give it down to the workflow, the model expander, the reducer, and the helper expander. And so that will be the target for this video, I think. Then once we've done that, then we need to create a transform. But that's going to be more complicated, because in order to do that, we need to teach the physical model about helpers, and that's going to require a bit of work around the templates. So that I think we need to do offline, because that's actually quite a complex bit. But nonetheless, let's just get cracking with these guys here. So I think what we can do is we could try to just, well, we could delete these types, to be fair. Delete these two guys here and even element properties, and in the formattables, in fact, another thing we could do as well is get rid of the streaming properties. So let's just start with that actually. So I'm going to delete the streaming properties here. In fact, I'm not actually going to delete it first. I'm going to go to the helper expander, and you should see that there's streaming properties just here. And where we're supplying the configuration, I should think, so populate helper properties, I should think. This guy here is probably supplying them across to this other guy. So what we'll do is we'll say something like this. Just bring us across the streaming properties as they are. We shall use them. Max is thinking a little bit. So we shall pass them over to this guy here. And then we will pass them over to this guy here as well, which will remember the properties. So this would hopefully give us a quick win, because now what we can do is we can now say please give me the streaming properties, and then we can also say please give me the streaming properties here. And finally, in here, we could say please initialize the streaming properties with whatever you got there. And now, where we say helper configuration dot streaming properties. Oh, actually, we have some aliases, so that's alright. That's not a problem. Right. Okay. It seems like we don't actually use it directly just yet. So one more. So it must be a compute helper properties around here somewhere. And sadly, there probably is going to be a walk name tree. Now this is all like getting a little bit ugly, but if you bear with me, it will all hopefully make sense in a minute. So what we really want is for wherever we are using the streaming properties at present from the configuration, we something not quite right here. Okay, so let's just double check that we are actually using the streaming properties around here. We may not be using. I suspect we are, but I'm just gonna quickly do all this. Interesting. We don't seem to be using the streaming properties around here. Let's try before we let's just try to understand how the streaming properties are being used. So there we are. So what we really want, what we really care about is who is calling streaming properties for ID. So walking name tree is, so we were in the right track. So instead of supplying a configuration, this guy here is going to supply us just the streaming properties. So hopefully you should be able to understand what we're doing now. It's a great deal of hackery really, but we just want to isolate the streaming properties because in truth streaming properties are already being supplied from the model itself, and there's no need for us to keep several copies of it running around. I mean, half of this code really needs tidying up anyway, but we are just looking for a quick tidy up at the moment. So that should be fine. Now, in order to compute the helper properties, we will need our streaming properties, which looks fine. And now we just need to make sure. Okay, one thing we did not. Okay, right. So sorry. We got a little bit confused here because we were supplying the configuration, so we just assumed we needed to supply the streaming properties. Now, question to be asked here is, why is there simultaneously a property of type helper configuration whilst we are also supplying the helper configuration? Right, so I think actually, to be absolutely honest, I think this has gone a little bit wrong. So what we're trying to say at the moment is this: there is stream properties that come into this class, that's fine. Stream properties for ID, I reckon we can just make use of the global streaming properties for this, whatever that is. And I reckon as we walk in the name tree, well, these are just global properties. So I reckon we could just say whatever the global is, as well as whatever the global is. Well, when I say global, you understand what I mean. Of course, I'm talking about class level. So now then, so we'll populate the streaming properties for the class. And then we shall not use that guy there, but use instead that guy. And then here we can just unwind our changes, and if we've done our job correctly, we should have no differences after this change. Okay, that seems to be just about compiling. Nothing else got changed, so okay, we don't expect any changes whatsoever after this. We're taking whatever the model version is of the streaming properties, we're slotting it onto our little generator, and we are reusing those properties instead of preserving them in our configuration. And if this gives us a green light, which it should, we we ran our tests. Let's just generate everything again. New code generated, no problems. So let's just say text.cpp use global, no, use model level streaming properties, something like this, right? And now that we said that, we can now say, well, I don't really need these guys here, and that should help us with the configuration, because now we can regenerate this model. We have to do a few converts as usual. Sadly, our history is not helping at the moment. Converts text Dogen text.cpp .json, and then we can just indent, and that should give us streaming properties free C++ text model, which we hopefully okay, we have one case where we are using the streaming property still. We shall not in a second. And that will do its thing. So that will then lead us to a simple helper configuration. And while we're here, not entirely sure. Correct. So let's return to our coding area. So when we make the configuration quite clearly, we don't need the streaming properties. In fact, we're not going to even need the configuration in 1 second, but there you are. Okay. Now we should have an error. Here we are. And then we can get rid of streaming properties. Okay. Now that should hopefully take us there in terms of removing streaming properties. So remove from the helper config. Yep, it's all green, so that's not quite what I meant to do. So it's all green, so that's good. So now we can now turn our attention to the helper families. The helper families are being read out from configuration, and we've already got proper support for this, so what we need to do is to understand what this is all about. And I think what this is all going to be about is going to be this guy here. So all we need to do is to take these global features, whatever is left of it, hop over to the logical model. Now whether this should be the logical model or not is anyone's guess. I think it probably should, given that the transform is going to be here in a minute, but there you are. And then we're just going to create a feature bundle here. This time we're going to give it a slightly more sensible name. Let's copy across the color. Right, so this guy would now be called something like helper helpers perhaps, and then we could say that well, we do want to generate the static configuration, so we can just get rid of that. And then we could also say that we need helper, and then well, we can now just copy the family bit. Doing this the slow way, I think. Plus variability bit. Plus the default. Okay, so now then, this guy here will now do his job. We need to, as we always have when we do this sort of thing, we need to remove it from here. And if we just go up to our model, we generate as usual. Now we have to be careful here that we want to convert two models. Let's just do one at a time, probably. Oh no, let's just, while we're here. If I just change this to indent to JSON, and then the logical. Righty, so hopefully what we should end up with is the movement of the feature across to the logical model. And that should be a fairly innocuous change if all goes according to plan. What's interesting? Okay, we seem to have removed all of the features, so in fact this is a bug, I believe, so there should be a feature registrar of some kind. There we are, feature initializer. So let's just put a comment here saying feature initializer with no features is not compiled. We removed all the features from and the compilation failed with the following error. So I mean, of course, it makes no sense to have an initialize without any features, but to be fair, we wouldn't expect that to fail. I mean, it's fine to have something. I mean, you could have a warning, perhaps. In fact, let's put that in the comments. We could perhaps issue a Dogen warning for the absence of features, but the code should compile. Which then means we need to now get rid of this guy. We've modeled, we captured the story, so we're happy enough with that. Not sure if that's quote or not, but doesn't really matter. We are clocking, and we are recording. Yeah, we are 20 minutes. Okay, so now then, let's restart our little exercise. We need to convert text.cpp and ident. And now let's just make sure that initializer is gone, which it is. And now I suspect we will now have another break, of course, because somebody must be calling the initializer. Yeah, of course, I forgot to generate, so now presumably somebody should be calling that initializer. Bootstrapping, that's fine. And so we just need to remove the initializer. Now, interestingly enough, we have the same feature in C#. Well, actually, we can't possibly have the same feature in C#, otherwise it will fail. It must be called C#.cpp. Yeah, so I think what we're going to have to do actually, we shall change this slightly to MASD, and then cpp.helper.family. Now, of course, as you can imagine, this is all a big hack, but it's fine. We don't mind that hack because helpers are to be removed, so we shall go as we are. So if we just convert the logical model, and oops, what we really meant to say is to indent the logical model as well. I don't think there'll be anything in the text model, but there will be this change in the logical model, so that's fine. Okay, and if we've done our job correctly, at this point in time, the feature should have moved to the right place. So, if that was indeed the case, which it is, let's just make sure the latest code generator generates what it should be generating, which it does. Right, now then, so logical, move helper family feature into from text.cpp model, something like this. Right, that now takes us where we want. And all we need to now do is to say in the helper expander, don't actually bother generating all of this. We will actually just supply the feature model. There shall be no feature group, just the feature model itself. And what you can do is you can say reuse the generated feature code instead of the hand rolled. So all is gone according to plan. So yeah, as you can see here, we're making the feature group. Don't need that anymore. We are taking a feature model, and we can tidy this up ever so slightly. Right, there's the feature model. It has to be called feature model because we already have an FM. And now we can use some other transform that we've played around with recently. Perhaps the labeling transform. As it appears it doesn't, so we must have a transform that we played around recently that contains string properties, perhaps. Configuration selector, this is what we're looking for. So if we grab configuration selector, we already had it. Don't think we need the feature selector anymore. Let's have a look. And with the configuration selector, we could... Oh, in fact, to be honest, I think we've done it the wrong way around. What we need probably is the feature selector. Because what we do here is... no, to be fair, we don't need either the configuration or the feature. We need to go straight to the logical model. Okay, so if we just do something like include Dogen.logical, in types. And now if we go to perhaps features, there should be helpers here. And once we got the helpers, we can create the static configuration directly and populate things across. So let's just look for the unused parameter. You see here we're doing a configuration selector. Well, let's just create the static configuration, I should think. Something like this. And helpers perhaps. Of course, we probably need something like using logical features helpers. Clearly we can't spell. Okay, so now then, and the feature group, yes, we did forget to generate the feature group. That's fine, I think. Let's just create them here. That's what we're missing, I think. But we don't necessarily need to make this too fancy. So let's just say we move things across ever so slightly. So if we say something like this, helpers take the feature model. Notice that we don't want the model as in the Formatables model, we want the feature model. Now we want to say, please create the static config, and finally, if all's gone according to plan. Interestingly enough, we didn't check to see if there is any config, but let's preserve the semantics here. Interestingly enough, we have the same name for both the C# and C++. So whilst that would work from the perspective of defining a new... Whilst this works from the perspective of defining a new configuration entry, in other words, we can easily do C#.helper.family. Sadly, because we are calling this family, we're going to end up with two families, I think, which is not ideal. Let's just have a look. Is that definitely family? So I don't think this is going to work. But nonetheless, this should at least take us as far as the C++ refactoring. We'll go with that, and then when we get C#, we may end up having to do a big rename of this property to something like helpers.family instead of having technical space in it, because we just need this to work, so it doesn't really matter. It doesn't have to be perfect. I know you've heard me saying this a lot, but helpers are definitely going to be decommissioned, so there's no need to make it too special. Just sufficient that we can maintain it for now. So now, if everything is going according to plan, we should be able to remove that helper configuration class. Let's try to run the tests. Whilst that's compiling, we'll have a look at Git. And we could say something like use features, helper features from logical model. And that's green, so we're happy with that. And what we also want to do is rerun the code generator as we always do after any changes. Make sure something that didn't get captured by the tests didn't fail. Now we can get rid of this guy. And as usual, we need to indent. No, actually, the wrong way around. It'll be so pleasing actually when we finally get rid of JSON and dia, because it's painful having to do this all the time. I mean, it was useful, don't take me wrong. It did have its uses, but now it's more of a pain. Now that we know what we need, it's more of a pain than anything else. So let's remove that class and let's run all tests. I suspect we will have problems. helper configuration. And no, we are still using the configuration. We made a mistake here. So we are still using the configuration as such. What we meant to say was, just gonna quickly undo this. What we really meant to say was, let's have a quick look at how this type is being created. So where we have a make configuration, sorry, we just took a one step too quickly there, but doesn't really matter, we can still do it. Helper expander needs to return logical ID with a string. You see what I mean? And the populate properties now will contain the map itself by reference, and this will be called something like helper families. As you can see here, this is probably something worthwhile noticing. What we tend to do is we tend to do these extraordinarily incremental changes. Probably could do things faster, and probably if I was working on a professional code base like work, I would do things a bit quicker. But here, in Dogen, we do things extremely slowly. And the reason why is because we actually believe that by going slowly, we end up going faster. In other words, we tend to, if we make very big changes, we tend to break things, and then it takes us a long time to understand where things broke. Right, so as before, let's just say const bloody blah by reference helper families. There we are. And if we could supply that as a parameter, and that will be something like this. And then when we look for helper family for ID, we no longer need that. And hopefully, see, this is what I mean about concentration. The reason why we've done that jump was because we are not fully concentrated in the code, which then makes things a bit slower. Programming is largely an activity of concentration, really. So helper families. Now, so I'm not entirely sure what's going on here. Well, we got errors, but let's just ignore those errors, and let's instead focus on these chaps. So I think that would do. Not sure where I still have too many errors. Okay, now walk name tree. We don't want walk name tree to have a configuration. So we could just basically say, well, don't need a configuration because we have what we need in memory. It's a class variable, and then with that we simplify things a fair bit. Oh. And then we could just call this guy, and there'll be a call here to walk, but there we are. And finally, should probably just do a series of very simple mop-ups, I think. It's all very old code as well, which explains why we were doing things the complicated way. Right, now then, expect a couple of errors. Right, so no needs for CFG. No needs for CFG. And no needs to make the configuration. We need... Oh, interesting. No, we just have to be slightly careful here. Where we say make configuration, we need to return this guy instead. Which then means this will be just R of ID. Okay. And finally, right, to populate the helper properties, we just need, wherever we were doing the CFG, we just need the helper properties. Sadly, we're just a tad too big, so we're going to have to do something like this. Okay? So then, now, when we try to recompile, hopefully there is no mention of the configuration anymore. And we can delete this as we did before, save it. And hopefully this will now take us where we want to be. So, recompile the code generator, rerun the code generator, and let's just commit all of this. So, we could say something like text.cpp remove deprecated helper configuration. There we are. We got rid of the helper configuration. Now then, the second step will be to get rid of the helper properties. For this, we've already got them in the right place. This will be slightly more complicated because once I drop these two guys from here, everyone needs to point to the logical model ones. So really, what we want to do is to do this in two goes. First, we'll say don't use these guys, use the logical model ones. So this will go up to the logical model and use the properties in the logical model. But what I mean by that is it's not going to use the ones inside of the element itself. It's going to use the element properties first. Although having said that, we already have the element in the element is already available here, as you can see. Elements. So there's nothing stopping us. Well, I mean, it's not exactly the most complicated thing to just point to that instead of to the element properties. That indirection doesn't seem like it's gaining a lot. But nevertheless, as I say, we should always try to do things in very incremental steps. It may appear this is trivial, and then we start doing it, and then it's not, and then we end up spending time, which we do not have, cleaning things up. So always best to do very, very slow and incremental steps. Right, there we are. So now then, I expect a lot of breakage because everyone is referring to the helper properties will moan. And so hopefully, all we need to do in this case is to say logical entities and then helper properties forwards. And similarly here, if we just go to entities. Now I think sadly this is gonna break all of our transforms, because I think the transforms interface is code generated. So anyway, let's see what happens. So if we right, so I presume this is going to be, well, in this case we could probably get away with something like this, using logical entities helper properties, and then the helper descriptor. This actually will address a lot of our problems, believe it or not. And then we just need to mop up the rest. Let's go up to the generation area. So as long as we don't have any references to helper properties, okay, bug, annoying bug, we skipped, and here you see a classic example of why it is that we do things so slowly. When we model these types, we skipped name qualified somehow. So now we have to go back here and come back a little bit. Name qualified, just a string, very easy, just after name identifiable. You can start to see a little bit why it is that we are so incremental. It's because when problems like this occur, they're very easy to fix. Now we can put this back the way it was, which was just simply something like logical entities and the helper properties. Right, now then, we need to regenerate. Now the problem we have is we are already in the middle of all these changes, and there is no easy way to do this. So let's just attempt a stash here. Don't really care what I call my stash for now. So let's say I attempt to just generate the logical model. And the usual conversions and indentations. So now hopefully we just added that one property. I think something didn't quite go right. Convert Dogen dots logical, if I could type. And a bit of luck, if the compilation gods are with us, we can run our tests with just a missing property. Now of course you can imagine we touched element, which is kind of like very central. So, and on top of that we already had modified a couple of files as well. So what are we doing for time then? We are entering, well, 45 minutes, not too bad. Don't think my original ideas of removing all of the types and formattables, all the helper related types, was a bit ambitious, but we'll keep going. Let's see how far we can take this exercise. Water perhaps. Don't think we did any builds today, but let's have a look. push anything yet. So I was mentioning before, the release notes for the previous sprint are out, so have a quick look. There's links for everything, links for the demo, link for the videos that we've done, and there's the list of the videos for this playlist, which we are in part 19 at the moment. And also some notes on our presentation for the Association of Angolan Programmers. So it's quite a good release, really, all in all. And we're actually quite looking forward to the end of this sprint, because it could get us in a very, very decent shape if we look at the stories that we got lined up for the sprint. It's actually quite exciting, because pretty much with less than 10 stories we can go all the way to a very, very good shape. Now you can probably see why I was so ecstatic on the release notes, talking about how important this gap, or this bridging the gap approach was, because something not quite right with Tremax. Let's do a refresh. Interesting. Not quite sure why Tremax is erroring. Nothing to refresh, apparently. Normally you can see the stories over there, but well, at any rate, oh yeah, we go. Compilation is done as expected. Everything's green. Build the code generator as usual. Regenerate the code generator, and life is good. No changes. So logical add name. What was that we added just now? Name qualified. Not qualified name, I guess. To help descriptor. Now we can go back to where we were, and with a bit of luck, we'll have a bit less errors this time round. Okay, so now then we need to worry about the assistant. Now I think here will be similarly just a few session replaces. I'm just gonna look for upper properties just in case. Alright, there's a few entries here. So what we'll do is, we already know where these errors are going to come from. So let's just have a quick look at the usages of helper properties around here. And just fix these guys, because they will break in a second. I can't quite remember how much we copied. And in fact, we probably just want the namespaces, because that would save us a little bit on copy and pasting. So you can see we're just literally switching the lights off on formatables 1 and 3 at a time, very slowly. And very carefully, because this is all very tricky code. We start to rock the boat a bit too much, I'm sure it will collapse, and in ways that are very hard to then fix. It'd be nice to have this somewhere in memory. Don't seem to, it's fine. Now, I wonder, where are we? Associative container help. Okay, right. See, we are now. Right. So what we need to do here is we will need a bit more of an aggressive approach to these, because what's going to happen in a minute is we're going to end up with hundreds of these guys. Let's go to our little grep stroke RG area. Let's do a quick grep for something like formatables helper properties. So as you can see here, we have 1 or 2 entries, right? As we'd expect. Few of these will be coming from the text model. not huge amounts. So what we'll do instead is we'll grab this and we shall change. Let's just change all these files in one go. Now you may think this is a bit aggressive and we may not quite get the right things here, but and also don't forget that we got open models, so we definitely don't want to save these open models. But it's fine. It should be okay, I think. And if not quite what I meant to do, we saved. So now let's do another grep now, and then we look for output descriptor. Again, in Formatables. And again, we shall just I forgot to copy, but doesn't really matter. So logical entities helper descriptor. Right, so now then, it's gone across the whole world and replaced, but of course, while we're there, it would make sense to also do a grep for the headers themselves. So if I just do something like this, Dogen dot text.ctp slash types slash formattables. I could really copy this, but in fact, to be honest, I will copy this because we'll make some typos and I'm going to be annoyed. This guy would do. So if I just go back to our RG area and I'll just do a quick search for this file. See quite a few entries here. We can again we'll grab it and then just change this guy to the right header file. Save the guy, no problems. It's a shame it's not super fast, but problem is you open the file and then that triggers the LSB mode. And this would have been very quick if it wasn't for LSB mode, I think. Scripter. Hopefully there's no entries for that guy. And now, with a very huge amount of luck, while this is going on, we will actually stash everything. Except for our sprint log. As you can see, we modified the models as well. So now then, with all of this hackery, we can open up safely the models again. Not quite sure how to disable the rulers automatically. And C#2. So with all of this hackery, hopefully we got to the point now where majority of our stuff, that's problems. One mistake we did is we shouldn't have touched C# just yet. Right, there's a slight mistake here. We've gone a little bit too crazy. That's fine. We know what they are. So all we need to do is to unstage all these guys, and then if we could, I think we could just take all the C# guys. Slow at the moment. Well, I got almost done with C# guys anyway. So let's just take all of the C# guys plus the model itself. So we don't want C#, we don't C#, and we don't want C#. So I think everything else is probably alright, I think. And then in here we shall ZI C# changes, something like that. Right, now then we shall just try to do the C++ changes at first. And what we'll do is make sure we close that model. Right, the idea being that, of course, as you can imagine, we have oops. As you can imagine, we have a type with exactly the same name in C#, which we haven't done any work on yet. Two types, in fact, and they are being picked up by the grep, and we don't really want to do them just yet. We want to do the C# C++ ones. I mean, it probably could do the C# ones at the same time, to be fair. But as you can see here, there may be some very slight differences between these types, and we also haven't done the rest of the work in C# anyway. So it's best to just one model at a time, as we always say here. Now then, that looks good. Let's make sure we stashed. No, we did not stash. We're going to stash everything. Let's run the code generator. No changes should occur, and they didn't. So you can now say text.cpp remove deprecated types helper descriptor and properties. So helper properties and descriptor. Okay, so with that we now are in a very good position because we've got rid of the bulk of the stuff, and now we can do the change that we wanted to, which is to get rid of the element properties. So at that point the formattable will become rather like we have in a text model, a logical physical region space, which is what we want. So we are getting quite close now, in C++ at any rate. So if I just get rid of, in fact for this video we shall only do C++ because we've already got an hour worth of content. So righty, so then let's get rid of the helper properties. It's quite satisfying actually. And now again we're going to go through a similar process. Conversion, really at this point in time I should really create a couple of functions here in Emacs to remember all of the different compilations. So we don't have to remember to type them and make mistakes. Right, so let's just, I mean I'm sure we have an up-to-date code generator, but double check. Okay, so interesting. Somewhere we are still using element properties. Wow, maybe the assistant? That must be the assistant. No. Very interesting. So at the moment we're getting an error. Let me just show you what the error is. Somebody is referring to the formattables element properties. Now, because we don't really have proper outputs of the errors just yet, it's in our backlog for a long time, the only way to get that is to sadly debug log. Bit sad really. So many things now, to-do lists. Proper warnings and errors is definitely one of them. So if we look for logging somewhere around here, and just, well, to be honest, it doesn't take that long to run all the models with logging. And let's just jump over to the log probably takes us longer to find the logs than it does to run. And if you look for the text.cpp model, and here we'll have the error with all the needs, the relevant information we need. And what is failing to resolve, I wonder if I can just check here this guy. Here I can. Ah no, there's two things here, isn't there? So if I just go forwards, then JQ it, then JSON mod it. So the chi that's causing all the problems is context. Now context is actually not co-generated, funnily enough, but well, now we know we're going to have problems in a second. Right, so let's just get rid of that guy for a second. There might be other things we need to do here, but that will do. Now before we do anything else, let's remember to unwind the logging changes. Run this again. Now we got rid of a whole lot of properties. We've already done that, so that's good. Okay, so now then, expect a lot of breakage, as you can imagine. So okay, the first breaks are actually not the kind of breaks I was expecting. These are just to do with bad includes. So if I just say include vision.logical types entities, one thing that's a bit annoying is there is a fix me available, but there's no easy way, I don't think, from LSP to just say give me a fix me. That should be quite useful. But there you are. Okay, so this solves the simple problem. And the more complicated ones are going to start now. So first, we don't really need you there. Second, we don't want to supply these to the guy. Now one thing that's like, yeah, now it's fine because we have an element, I should think. So as long as we have an element, and I suspect we must have an element somewhere. Okay, we don't seem to have an element here. Well, this is a context, so I guess it shouldn't really have an element. Not sure why there is an element properties, but there you are. So if I now, we'll just make the context compile, and then we'll have to use some imagination to try to understand why the context add the element properties. Similarly, yet again, we are having inclusion problems for the string properties, I believe. Maybe not. Right, so then, now the bits that are more interesting. So, we have the elements. Let's just say that there is formattable elements. We actually don't care about all this nonsense. Just give me my formattable element. This is going to go away and create the helper properties. And then if we just do E, helper properties, that does not quite work. Disappointing. I was hoping that would just work. I think I'm going slightly blind here because that does exist. So the problem must be that somehow we made the wrong type in helper properties. Let's have a quick look at what we think the type should have been. Stood list of logical entities helper properties. Now that sounds rather like what we have. Stood list of helper properties. Did we make it const perhaps? Yeah, we made the element const. Okay, let's unconstify it. Right, now we're going to have a lot of breakage all over the place. So, so I guess in cases like this we need to, well, let's just focus on the assistant for a fair bit, because the assistant is going to be one of the major users of this guy. So let's just see, what does the assistant think these guys are used for? So, right, this is a bit of a problem. So, no, actually that's not too bad. So, well, we just need to understand where we're using these element properties, I guess, because seems to me, oh, are we even using it? Okay, always the best when we don't even think something is needed. Now that'd be quite hilarious. Not sure what is going on here. We should be using the element property somewhere, I think. Ah, it's because we were going straight to the context. Okay, so I think that might be a good change. And then we just need to say something like this. Well, you must have an element, presumably. And that element is capable of having helper properties. Well, now we seem to hop over to the context. See, the semantics here are changing ever so slightly. We started off by looking at the helper properties in the element, and well, in the assistant. Then we jump over to look at the context element properties. We loop through all of those. This code looks awfully confusing. I'm going to take the liberty of thinking that we just got a little bit crazy with the refactors here, and what we really meant is this. And with a bit of luck, they're semantically equivalent. And in here, as you can see, we're sort of alternating between the context and the elements, and I'm not sure that there is a huge difference between the two. Well, we should soon find out. Bit of luck, there isn't, but so where are we then? Yeah, as you can see here, we are really getting to the point now where we could almost apply a logical model here. And that's what we're going to do next. So we will supply a logical model to the Formatables transform, quite ironically. Go through all this workflow with the logical model. No changes in any of these guys, and then that will allow us to get rid of the adapter. So just very slowly, very incrementally, we keep chipping away at the problem, and presumably here we are going to perhaps create the... What are we doing with these element properties? Creating the context. I do not think these are required any longer. And now the big question will be, are they the same or are they different? See, although we said we're moving quite incrementally, you can already see that there is a lot of changes in just this one commit. And when things break, which they did, now we need to understand why. So the key thing that's happening here clearly is that there is a difference in semantics between the properties in the element versus the properties in the context. I don't understand why, so we have to understand what's going on here. Quite a few changes. Right, okay, so let's think for a second. Let's start with that workflow we were in a second ago. And the workflow... Well, I thought it would be the Formatables workflow, but clearly it was the transforms. So, in the transforms workflow, what were the element properties that we were looking at? So we went to the formattable element properties. Right, okay, that sounds about right. So as you can see here, right, so this makes perfect sense. Well, it doesn't make perfect sense, means the code is completely dodgy, but it's what we expect. You're going to the formattable, you're obtaining the element properties, you're supplying the element properties to the context, and then you're supplying the context to the assistant. So in effect, we just lost the plot slightly after many refactors, and we were now duplicating the element properties, which is also a fantastic name, really. And then what is happening at the moment is we simultaneously have the element properties in the assistant, we have them in the context, and we seem to be alternating between the two. That, I think, is fine. However, we seem to have changed the semantics, which means we are no longer populating... Oh, I wonder if it's something quite as simple as the helper expander. When we said let's make this mutable, I wonder what we did. So let's have a look at what we're doing here. So we took the element in the formattable, we computed the element properties, and then we slot it back in. And that actually does not look too bad, if I'm honest, because let's think about this. It should have updated the element property, shouldn't it, really? Well, I mean, previously we were updating the element properties from the formattable, so I don't think there's any difference between updating in the formattable and updating the element itself. As long as we don't make a copy of the element, which we don't seem to, so we're just basically taking the pointer, dereferencing it, obtaining a reference to it, and then doing some stuff with it. And what we have done quite slyly is we changed the type of the visiting, which means this does not longer work, which means the visitor is no longer visiting. is a rather annoying thing. This has happened to us a few times. I hope this is sufficient. Right, so what's happening there is simply that the visitor was no longer visiting, which meant we're not populating the upper properties. So our deductions were correct, we just were short of one thing, I think. And see, this is a great illustration why we need to keep the diffs small, because when they break, it's difficult to figure out why. Most interesting. No, that's actually not a big problem. We probably just forgot to convert. Well, actually, it appears we did do a convert. I would have thought this would just be a problem with the convert, actually. Okay. Perhaps say something is not quite there yet. So, that was actually quite satisfying in the end. So we managed to get rid of the element properties. So you can see we're slowly converging the Formatables model to the point where it is identical to a logical model. And there we are. Just what we wanted. Now let's just do the commit. Remove deprecated element properties. And now we're going to do the big one, which is get rid of the model. This will cause a lot of noise purely because of the references to the model. But in terms of actual code changes, we expect them to be very little. We will have problems with names. Element and artifacts don't match the LPS model. That's about it, really. So we're just going to go ahead and do it. Has been quite a few sprints incoming. The removal of the Formatables model. We do have the adapter as well. I don't think we can get away without removing both at the same time, because the adapter needs to adapt. So yeah, I'm afraid there's only so much we can do in terms of incremental deletions. That has to go. It'll be quite difficult to do this in 2 goes. Right, that is a pre-empty Formatables model. And now we are going to have a bit of a bad break. Right, we'll just leave these models here. The code generation will be fine. Oops. Okay, fine. We have references all over the place to these models. Now, I wonder if we should we will reference the logical model here. I mean, we should really not have a reference to the logical model inside of the context. That's not what contexts are for. But we are not here to fix the entire architecture. We're here just to try to move over to the next problem. Let's just try to generate first to see how much. Okay, that was just the one. So yeah, as I said, we're not here to fix all the problems of the world, just these. We will worry about why it is that a context is carrying a whole model later. Now, this will break, and we already are an hour and 20 in. Right, so what we need to now do is to say pretty much, well, I think I'm just going to follow each of these one at a time. So there shall be no formatable. where we had a model, we would have a logical model. Hopefully that would take us there. And right, in certain places around here we were taking liberties. Oh, actually, do I really mean a logical model? I don't think I mean a logical model. I mean a text model, sorry. Text. And that then means that if I go to the text model, if we'd like to carry out the regions, so what did we have before? We had a map by logical ID of formatables. Now there is no such thing anymore. We could either deal with logical models or physical models, and I think actually, believe it or not, we could probably get away with a logical model. So sorry, let's go back. Bit of a gamble here, but I think it will work. And because the logical, no, actually no, sorry, I take back. The logical model does not have a flat view of all the elements. So that means we need to change the existing code. There's never anything trivial around here. So the logical physical regions are also not indexed by logical elements, so it's not going to help. So we need to re-implement the helper expander. Well, so let's just think about this for a second. Where is the helper expander going to ultimately go? It's going to go to the logical model, right? So it should really deal in terms of logical models, whatever the pain. And further, so let's just first start with that. We'll just have a logical model here. We can now finally call it just model. And we will just, which also means we can now call this guy a feature model, which makes our life easier. And now I'm going to say, please supply me with a logical model. I actually don't think we need a map by logical ID. I may be wrong, but we'll soon find out, I guess. Now, cost seems not likely, so we'll go with non-const. Okay, cool. So, in fact, I'm just going to jump over to our programming area because this is going to get messy. So we'll start with the easy changes, I think. So here we just need this, and here we just need something like fm, m, and here we will just need something like m. That's alright. Then here we will need m, and then things will start to break. So we had a visitor. Oh, actually, I wonder if we could just do something as simple as convert our visitor to something slightly more. Right, so we could probably move. Yes, let's just change the logic slightly here. Let's basically say let's not operate too much on the model type beforehand, and then once we do the dispatching on our visit right now, not clear why it is that we're dealing with them separately. There is we're basically looking for things with attributes. Right, fine. So it's okay. We will duplicate the logic here. It's not a big problem. Well, I'm actually going to take this blurb here because this is not going to make a lot of sense in the future. And if I just then say something like this, and we repeat the same approach to this guy. Okay, so that solves that problem, and then we have the helper. Now I just want this to be very, very small. I want to go to the model, and then let's just look at a traversal. Oh, we are pointing to the wrong mod, so context. Let's fix context first, because this is just going to create a lot of errors. So we want the context. Well, actually, let's think about this for a second. Right, I think the reason why we have a model in the Formatables model in context, well, sadly I don't think we can do references at present, but let's have a look. Oh no, we can. Okay. So context is used. I think the references are a little bit confused. Right, okay, what we're going to do, we're just going to take a step back for a second. It's not a massive one, but let's just take a quick step back where we are going to get a compilable code base again. What we're trying to ascertain is, when we have a model in context, what is that model used for? Because context is used on every single transform, and every single transform is going to pull in that header. So it's not ideal to have to deal with that. So it may make more sense to drop the model. Well, let's just see what it says. And I think, sadly, I think we are running out of time because we already got 1 hour and 30 minutes. I don't think we're going to get to the end of this today, on this video anyway. It's a shame. It would be a nice point to finish this. But I suspect it's just a bit too much for this slots. Right, while that's doing whatever it is doing, let's see if LSP is giving us a slightly more sensible references. Now I don't trust these references because that doesn't look like we're talking about the model at all. Neither of these look. But having said that, I do believe the assistant is going to be the one calling the model. So what I'm going to do is I'm going to look for context.model. And as you can see, no one here is talking about context.model. Now that's a bit worrying, I think. Well, depends how you look at it. Since we can't trust LSP, it's probably doing some update internally, we're going to do the next best thing, which is to convince context here we are. So okay, I'm not entirely sure what this guy is talking about, but I really want context.cpp, and I want model here, and I'm just going to call this model 2 just so it breaks. And now I want to see who is making use of this model. Now if it's no one, we will go back to our stash and just delete the model. We can't do it from here, sadly, because if we did it, it will probably cause conflicts because we already started modifying the context, I think. there's a lot of people including the context, as you'd expect, every single transform. But it's looking quite good. It seems this is some historical thing we added to the context with a very, very large set of consequences. Okay, cool. That sounds good. Okay, so now then let's think about this. So if that model is actually useless, let's just stop this because we don't really care anymore about this. Let's just then say, okay, fine. Give us our stash. Show us the context. And let's get rid of the model. So, formatables, model. We didn't update the model, do we? So, in fact, if I just do a quick check for formatables. So, we don't need the formatables model here. Sadly, I think we are killing the LSP because there's so many changes, so many files. The LSP is just getting completely lost, I think. Okay, that's that. And then if I then go to context.cpp, similarly, we should say, well, don't bother. Don't bother. That's actually, LSP is actually behaving quite well, funnily enough. Alrighty, and don't bother. I think we may have missed model itself. No, that's the physical model. Alrighty, so now then, context is not going to cause problems anymore. So everyone else will. Reducer. Now, this will be awfully difficult to do. Because this is a bit of a problem actually. We are removing all the non-target types from the formatables model, but we can't do that from the logical model because the logic, well actually we need to figure out, okay, this is actually quite a tricky thing. We need to figure out what the transforms, what they're working off. Well, they clearly would be working off the formatables model, so that's not much of a answer. But what we're trying to say though is, what does the adapter do? So if I go back to the adapter, what does the adapter do to the formatables model? And I think, not sure what this repository is all about. Just have to be very careful here. So we are taking this transforms repository. We are taking the logical physical regions. These fireworks are rather annoying. Right, so we don't care about segmentation, so that's not a problem. And then we are basically saying that if an element has no formatters, then we remove it. But largely, all that we're trying to do is we're trying to take the logical physical regions and we're mapping them to formattable. That's really the gist of this. That's what the adapter is doing. We have already removed the adapter, so that's not a problem. We can just literally just get rid of adapter and adapter. That's fine. Reduce, however, is a different story. In the reducer, we need to go through every single logical physical region, and we need to remove those. Well, we have to remove two things. We have to remove those where the element has no formatters. I think we can just let that be. I think it's fine. But more importantly, we need to remove those that don't belong to the target model, I should think. And that's the job of the reducer at present. And I think that's where things are going to get tricky. Ah, okay, that's simple enough. So we should probably just get rid of the reducer altogether, really. So the right thing to do this is to say that after we've generated the logical physical model, we just reduce it, because after we've done, so the right place to place this in will be somewhere in orchestration, I should think. So now we're entering slightly more complex work, which should really not be done with live coding, I think. So we need to make sure that we perform the reduction after we've executed the legacy dependencies transform. And so that has to be done around here somewhere. So we need to create a new reducer. And that has to go here. Okay, so let's just recap where we are at the moment. So we won't be able to do the transform as we are, the change that we're trying to do just yet. The reason why that's not going to work is because there's only one tiny thing stopping us, and that's that reduction has to occur, but reduction can't occur in here. It has to occur, well, the right place for it is slightly higher up. We could probably do it here, but if we do, we'll generate an inconsistency between the logical and the physical. Well, we will generate an inconsistency between the logical model here and the logical physical region there. So we want to remove both at the same time, which means we want to work at Dogen text model level, which is this guy, the LPS. However, what we don't want to do is we don't really want all of these guys to deal in terms of the text model, because they can just get away with the logical model, because the helper expanded transform is going to go into a logical model. So in fact, to summarize a very complicated argument, this guy is going to live in the logical model, this guy is going to live in the orchestration model, and so therefore there's an inconsistency between the different model types that they require. And so in order not to write too much throwaway code, the right thing to do is to move this transform first, and then return and move these guys here to use the logical model, and then finally move this guy over to the logical model, which should be quite straightforward to do. So what we need to do then is we need to stop for a second what we're doing, yet again. We're happy enough with the context change, so that's fine. So let's just call these remove formatables model. So you should really name your stashes if they are going to be very long-lived. As you can see, we already have 2 stashes on the go. We shouldn't really have committed from here because we lost our flight check. And what we're going to do now is we're going to do the following. First, we're going to get our code generator back. That will be easy enough. But more importantly, we will we have to be very careful not to modify text.cpp. I'm not sure if we should continue recording really, because almost 2 hours in, 1 hour and 40, and the next bit of work could be quite tricky. But well, let's just try. What are we doing for time? Oh, it's actually quite late already. Okay, I'm afraid we're going to have to stop now. Okay, so to summarize then, we got very close to removing the formatables model. Very close. We just couldn't quite get there yet because of this little incompatibility between the different kinds of transforms. But once we've got those transforms out of the way, hard to believe, but we will be able to get rid of the remaining stuff in the transforms namespace. However, we will stop here because the next 2 bits of work, well, first because we ran out of time, but also because the next bits of work might require a little bit of concentration, so it might be easy to do it offline. And then we'll return once that's done. Okay, thanks for watching.